Okay, we're starting on chapter 12. Chapter 12 is all about patterns, basically. Fancy name for saying patterns in math land is sequences. That's all it is. So the whole point is I want to be able to see that you can see the pattern and describe it. So if you look at this first one here, 1, 4, 9, 16, 25, hopefully that should spark a light bulb in you, and you should think, oh my gosh, those are the perfect squares. Look at the next one. 1, 2, 3, 4, 5. What's happening each time? I'm adding 1 each time. 3 to 6 to 12 to 24. Ooh, I'm multiplying by 2 each time. And the last one, I got kind of 2 things happening. I have 1 on top. On top of this fraction, it's adding 1. And on bottom, it's adding 2. And it's like just like odd numbers. So hopefully you can recognize patterns and be able to describe them. A finite sequence and an infinite sequence. Well, infinite means goes on forever, so it's an infinite number of terms. Goes on forever. A lot of the times, like we see up here, it's got that dot, dot, dot. That means it's infinite. For finite, that means it ends, has a stopping point. Terms. Your terms are your actual numbers in the sequence. It's the numbers in the sequence. So looking at this, this example, 2, 4, 6, 8, next one would be 10. I'm looking at what is my first term. My first term is 2. My fourth term, 8. If I kept going, what would my 10th term be? Well, if I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I just use my fingers to count up to 10 by 2s, and I figure out my 10th term is 20. Now we have some different notation for this. We use it, I don't know why, but we use to find the first term, or to talk about the first term, we talk about A1, A sub 1. That means my first term. For my second term, I'm talking A sub 2. For any other term, if we want to find any other term, we do A sub n. That'll give me any other term. For domain and range in this, domain is your input, range is your output. So input, your domain, that's what number you're plugging in. Your output is what those are actually your numbers in the sequence. And we're leading down there, so explicit rule, that's just a formula in terms of n that will allow you to find any term. It's just a formula. It's a fancy name for formula, that's all it is. To find any term. So here we go. Here we got our first example. Given the explicit rule, here's my formula. Write the first 3 terms and the 50th term. So for term 1, my first term, I plug in 1 into n. 2 times 1 plus 5, and I get 7. For my second term, I'm plugging in 2 for n. 2 times 2 is 4 plus 5, 9. Third term, I'm plugging in 3. 2 times 3 is 6, plus 5, 11. And if I wanted to jump ahead and find my 50th term, I plug in 50. 2 times 50 is 100, plus 5, 105. Other one, for my first term, I just plug in 1 over 1 plus 1. I got 1 over 2. Second term, I'm plugging in 2 over 2 plus 1, so 2 over 3. Same thing for the next one. Third term would be 3 over 3 plus 1, 3 over 4. And if I wanted to find my 50th term, I do 50 over 50 plus 1 is 51. Okay, let's keep going. These ones, okay, we got some more of these. So all we're doing is plugging in numbers. A1 would be 3 times 2 to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. 1 times 3, 3. My second term, 3 times 2 to the 2 minus 1. 2 to the first power is 2 times 3, 6. Etc., etc. You keep plugging in 1, 2, 3, 1, 2, 3. Okay, now we got something different. It's called sigma notation or summation notation. So here's the lowdown. This down here, that's called my index. That's my first term. That's where I start this thing. This n up here, that's my last term. And right in here, that a sub I, that's my formula. That's my formula. Now, just so you know, we don't always use I down here. So I'm going to put a little caveat here. Could also be K or N. For some reason, we use I, we use K, or we use N. I don't know why. Do not ask me. And all this means, this summation notation, this sigma, this big E looking thing, is that you're adding up terms. So I'm doing like A1 plus A2 plus A3 plus all the way up to my last term, which would be AN. Summation notation and series are very similar. Series is you're adding up a sequence. Adding up a sequence. So if I look at my finite, remember that ends, that's why there's no dot, dot, dot like there is this one. If I added these up, 2 plus 4 plus 6 plus 8, my sum would be 20. If I have infinite series, it goes on forever, what would my sum be? Well, if it goes on forever, it's going to be infinite, so I don't have a sum. Does not exist. Okay, last part. Find the sum of the series. So, it says I'm starting at 1 and going to 5, and this is my formula. So I need my first 5 terms. A1, A2, A3, A4, and A5. I need 1 through 5 because it starts here, goes to here. So A1, if I plug in 2, or I plug in 1 up here, 2 squared is 4. If I plug in 2 in here for my second term, 2 to the third is 8. If I plug in 3 into here, 2 to the fourth, 16. Do you see a pattern here? Multiply by 2, multiply by 2. So my fourth one would be 32, fifth one, 64. Now the last, once I have those terms, that big sigma means sum. So I add them all together. 4 plus 8 plus 16 plus 32 plus 64. Sum equals whatever you get when you add those together. I think it's 128. Let's check. 4 plus 8 plus 16 plus 32 plus 64. Oh, 124. I was so close. There you go. This one's a little different. See, this one starts at 4 and goes to 8. Starts at 4 and goes to 8. So I'm starting with A4, A5, A6, A7, and A8. I'm looking for those 5 terms. So if we plug in 4 into here, 4 squared is 16 plus 3, 19. Plug in 5. 5 squared is 25 plus 3 is 28. 6 squared, 36 plus 3 is 39. 7 squared is 49 plus 3 is 52. And 8 squared, 64 plus 3 is 67. And the last thing I do is add them up. 19 plus 28 plus 39 plus 52 plus 67. And I get 205. There you go.